Hi children, very good morning. I am Sagar, a mathematics faculty. I have 11 years experience in teaching. Today we are going to discuss about matrices. What is matrix? A rectangular arrangement of numbers, either real or complex numbers, is called a matrix. A rectangular arrangement of numbers, either real or complex, is known as matrix. The numbers in the matrix is called elements. Numbers in the matrix is called elements. Generally, matrices are denoted with capital letters like this. Capital A, 1, 2, 3, 4, 5, 6. This is called a matrix. Here, in the matrix, numbers are called elements. These all are called elements. So, in the matrix, horizontal line of numbers are called rows. Vertical lines of numbers are called columns. So, one see here, how many rows are there here? 1, 2. 2 rows are there in the matrix A. How many columns are there? 2 columns. 3 columns. 2, 3 columns. So, the order of this matrix is nothing but 2 by 3. General order is nothing but number of rows by number of columns. Number of rows by number of columns. If suppose a matrix contains m rows and n columns, a matrix contains m rows and n columns, it can be written as Aij. Matrix A is equals to Aij m by n matrix. Aij m by n matrix. This is called the order of the matrix. So we'll see matrix B. 1, 2, 3, 5, 6, 7, 8, 9, 10. What is the order of this matrix? Order is nothing but number of rows by number of columns. How many rows are there here? 1, 2, 3. 3 rows. How many columns are there? 1, 2, 3. 3 columns. So, this is called 3 by 3 matrix. The order of B is nothing but 3 by 3. See, one more matrix C. A, B, C, E, F, G. What is the order of this matrix? How many rows are there? 2 rows. By how many columns are there? 3 columns. So this is 2 by 3 matrix. 2 by 3 matrix. Next. The matrices, so many types of matrices are there. We have to discuss about that. So types of matrices. The first matrix is rectangular matrix. Rectangular matrix. The rectangular matrix is nothing but, in any matrix, the number of rows is not equals to number of columns. Number of rows is not equals to number of columns. Is called a rectangular matrix. Number of rows is not equals to number of columns. So this type of matrix is called a rectangular matrix. See, one example, matrix A is equals to 1, 2, 3, 4, 5, 6. See, how many rows are there here? 2 rows. How many columns are there here? 3 columns. So this is called 2 by 3 matrix. This is also called a rectangular matrix. Why? Because here number of rows are not equals to number of columns. So that's why it is called a rectangular matrix. See the next example. Matrix B. A, B, C, D. What is the order of this matrix? 2 by 2. 2 rows and 2 columns. It contains 2 rows and 2 columns. That's why it is 2 by 2 matrix. But it is not a rectangular matrix. Because here number of rows is equals to number of columns. That's why it is not a rectangular matrix. See the next one. A square matrix. Square matrix. A square matrix is nothing but in any matrix the number of rows is equals to number of columns. In this case only we can call the matrix is a square matrix. Number of rows is equals to number of columns. This type of matrix is called a square matrix. So see one example. A matrix A, B, C, D. What is the order of this matrix? 2 by 2. Because it contains 2 rows and 2 columns. So that's why this 2 by 2 matrix, it is also called as a square matrix. Because here number of rows is equals to number of columns. Okay. See one more example. Be 1, 2, 3, 4, 5, 6. Is it square matrix? No. Because here number of rows are not equals to number of columns. The number of rows are 2, number of columns are 3. So that's why it is not a square matrix. It is called a rectangular matrix. So the next two type of matrix is a row matrix. Next one is a row matrix. In any matrix contain only one row. In any matrix contain only one row. In any matrix contain only one row is called a row matrix. Is called a row matrix. See the example. A is equals to matrix 1, 2, 3. What is the order of this matrix? How many rows are there? Only one row. How many columns are there? 3 columns. This is the order of this matrix is 1 by 3. This matrix contains only one row. That's why this is called a row matrix. So the general order for a row matrix is order of a row matrix. Order of a row matrix is 1 by n. The general form of order 1 by m. Next one, principal diagonal. Principal diagonal of a matrix. Principal diagonal of a matrix. The principal diagonal is nothing but in any square matrix. In any square matrix, the line joining the elements from the first row of the first element to the last row of the last element is called a principal diagonal. What I am saying? A line joining from the first row of the first element to the last row of the last element. This is called a principal diagonal. See, I will give one a square matrix. Matrix A is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a square matrix. Order of this matrix is 3 by 3. Okay. Now the principal diagonal. What I am saying? What is the principal diagonal? The line joining from the first element to the first row. First element of the first row to the last element of the last row. What is the first element of the first row? 1. From here to here, last element of the last row is 9. From here to here, we have to join one line. These elements are called principal diagonal elements. Principal diagonal elements. It is applicable only in square matrix. Only in square matrix. See one more example. Matrix B. 5, 6, 8, 7, 2, 3, or 5, 4, 1. It is also a square matrix. So, which elements contain the principal diagonal? 5, 2, 1. 5, 2, 1. Okay. This is about principal diagonal. Next, come to diagonal matrix. The next one is diagonal matrix. Diagonal matrix. The diagonal matrix is nothing but in any square matrix. In any square matrix, the elements A, I, J is equals to 0 except I is not equal to I is equals to J. In any square matrix, all elements should be 0 except the elements in the principal diagonal. Okay, see the example. A is equals to matrix 5, 0, 0, 0, 2, 0, 0, 0, 1. Okay, see, all elements are equal to 0 here except the elements which are present in the principal diagonal. Principal diagonal means this is the principal diagonal. This is the principal diagonal except the elements in the principal diagonal. Remaining elements are 0. That's why this matrix is called a diagonal matrix. And see matrix B 1, 0, 0, 0, 2, 0, 0, 0, 3. This is also a diagonal matrix. Because all elements are 0 except the elements which are present in the principal diagonal. So this is about diagonal matrix. This is about diagonal matrix. Next, upper triangular matrix. Upper triangular matrix. Upper triangular matrix. In any square matrix, the elements of Aij is equals to 0. Here the condition is I is greater than j. Upper triangular matrix. Upper triangular matrix. In any square matrix, what I am saying, all elements not Aij is equals to 0, I is greater than j. That means, you see the generally we say that A is equals to, see this example, 1, 2, 3, 0, 5, 6, 0, 0, 7. One see now. This is the principal diagonal. The elements which are below the principal diagonal should be 0. Below the principal diagonal should be 0. Then the matrix is called upper triangular matrix. Okay? Next one is lower triangular matrix. Lower triangular matrix. In a square matrix, the elements Aij is equal to 0, where I is less than j. I is less than j. I is less than j. See the example, matrix B, 1, 0, 0, 2, 3, 0, 5, 6, 7. The elements above the principal diagonal should be 0. Above the principal diagonal should be 0. Then the triangle is called lower triangular matrix. See here, this is the principal diagonal. These elements above the principal diagonal. So these all elements are 0. That's why it is called a lower triangular matrix. Here, this is the principal diagonal. These elements are below the principal diagonal. So this triangle, this matrix is called upper triangular matrix. See one more example. Matrix C, 1, 7, 6, 0, 5, 4, 0, 0, 2. This is also called upper triangular matrix. Next one is here, see matrix D, 5, 0, 0, 6, 2, 0, 7, 8, 9. And see which elements are 0 here? The elements present above the principal diagonal are 0. Then this triangle is called lower triangular matrix. Lower triangular matrix. The next matrix is scalar matrix. The next one is scalar matrix. In any square matrix, all elements should be 0. All elements should be 0 except principal diagonal. So sorry. I'm saying about scalar matrix. No? In any diagonal matrix, all elements should be equal in the principal diagonal. All elements should be equal to, all elements should be equal in the principal diagonal. The principal diagonal. Those matrix is called scalar matrix. In any diagonal matrix, all elements should be equal to 0. Should be equal in the except should be equal in the principal diagonal. So see one example. A is equals to matrix 5, 0, 0, 0, 5, 0, 0, 0, 5. This is called a scalar matrix. Why? Because this is a diagonal matrix. The diagonal matrix, all elements in the principal diagonal are equal. That's why it is called a scalar matrix. See the one more example, matrix B, 2 0 0 0 2 0 0 0 2. It is also called a scalar matrix because it is a diagonal matrix. In the diagonal matrix, in this diagonal matrix, all elements are equal in principal diagonal. That's why it is called a scalar matrix. It is called a scalar matrix. See the next one. Identity matrix. Identity matrix or unit matrix. Identity matrix or unit matrix. Identity matrix or unit matrix. See, in any scalar matrix, all elements in any scalar matrix, the element should be equal to equal to 1. The element should be equals to 1. Then the matrix is called an identity matrix. See, matrix A is equals to 1 0 0 1. It is called a scalar matrix. And in a scalar matrix, the element should be equals to 1. Then that matrix is called a identity matrix. Generally, identity matrix is denoted with I, capital I 2 by 2. It is read as 2 by 2 identity matrix. It is read as 2 by 2 identity matrix. 2 by 2 identity matrix is nothing but 1 0 0 1. 1 0 0 1. 3 by 3 identity matrix is nothing but the order is the identity matrix order is 3 by 3. That is 1 0 0 0 1 0 0 0 1. This is called 3 by 3 identity matrix. 3 by 3 identity matrix. See, equality of matrices. Equality of matrices. If two matrices A comma B are said to be equal if the first condition should be the order of A is equals to the order of B. Order of A is equals to the order of B. The next condition is the corresponding elements in A. The corresponding elements in A is equals to the corresponding elements in B. Corresponding elements in B. See, when we are saying if the two matrices are equal, here two conditions are applicable here now. The first condition will be the order of two matrices should be equal and the corresponding elements in A and B should be equal. In this case only, the two matrices are called equal matrices. See, the first matrix A is equals to 1, 2, 3, 4, 5, 6. The second matrix is B 1, 2, 3, 4, 5, 6. What is the order of A? The order of A is nothing but 2 by 3. Order of B also 2 by 3. So both orders are equal here. Both orders are equal. And the corresponding elements in A and B. What is the first element of the first row in the matrix A is 1. The first element of the first row in the second matrix B is also a 1. The first row and second column in the matrix A is 2. First row in the second column in the matrix B also 2. First row and third column element is 3. First row and third column in the matrix B also 3. So here second row, first column element is 4. Here also 4. For second row and second column element is 5. Here also 5. Second row and third column element is 6 in A. In B also 6. That's why we can say these both matrices are equal. This can be written as A is equals to B. A is equals to B. See, I will give one more example. Matrix C is equals to 1, 2, 3, 4, 5, 6. So matrix D is equals to 1, 2, 3, 4, 5, 6. These two matrices are equal or not? Equal or not? Not equal. Because the order of first matrix is 2 by 3. The order of second matrix is 3 by 2. So both orders are not equal here. And also the corresponding elements in the matrix C and matrix D are not equal. That's why these two matrices are not equal. See, transpose of a matrix. Transpose of a matrix. Let us take one matrix A is equals to Aij. The order of this matrix is M by N. Matrix A is Aij. I columns. This matrix contains M rows and N columns. So the transpose of any matrix is nothing but we can interchange the rows into columns and columns into rows. Rows into columns and columns into rows. This is called a transpose of a matrix. The transpose of A is nothing but Aj. We can convert the rows into columns and the columns into rows. Is how many rows can be converted to the columns, columns can be converted into the rows. So the order of this matrix is n by n. So this is called a transpose of A. Transpose of A. Okay. Generally, transpose of A is denoted by A transpose. A power T. It is called A transpose. A transpose is equals to Aj. Or it is nothing but M by N. So this is about the transpose of a matrix. See, I will give an example. Matrix A is equals to 1, 2, 3, 4, 5, 6. Here one matrix given, A matrix. 1, 2, 3, 4, 5, 6. What is the transpose of A? What is the definition of the transpose? It is nothing but We can convert the rows into columns, columns into rows. So we can convert the rows into columns. 1, 2, 3, 4, 5, 6. So what is the order of A? 2 by 3. 2 by 3. What is the transpose of A? Order of the transpose of A is nothing but 3 by 2. This is about the transpose of a matrix. Next, I will give one more example. B is equals to 1, 2, 3, 4, 5, 6. What about B transpose? What is the order of B? 3 by 2. What is the B transpose? 1, 3, 5, 2, 4, 6. The order of this matrix is 2 by 3. So this is about the transpose of a matrix. Transpose of a matrix. See the next definition. The next matrix is symmetric matrix. Symmetric matrix. Symmetric matrix.